Well, let's take the question actually. Let's question 2. Radio waves emitted from an antenna. Question 2, please. Radio wave emitted from an antenna are picked up by radar. Are picked up by radar. That is RADAR. After reflection from an aircraft. Radio waves emitted from an antenna are picked up by radar after reflection from an aircraft in 4 times 10 raised to the minus 3 seconds. In 4 times 10 raised to the minus 3 seconds, full stop there. How far is the aircraft from the antenna? In bracket, they gave us C equal to 3 times 10 raised to the 8, meter per second. The options here, A is 6.0 times 10 raised to the 2 kilometer. B is 1.2 times 10 raised to the 3 kilometer. C is 3.0 times 10 raised to the 3 kilometer. And D, we have this to be 6.0 times 10 raised to the 5 kilometer. Okay, let's solve this question here, please. Class, whenever you are given any question in physics, this is the first thing you have to do. The first approach is to list out the given parameters. Do you get that? Now the next is to relate that parameters with the formulas you know. Okay, now let's list out the given parameters. That is given parameters. So class, read the question. What are the given parameters in the question, please? The time taken there. That is T is 4 times 10 raised to the what? Minus 3 seconds. Do you get that? Now we have listed out the first parameter given to us here. What again, please? They said what? They said what? How far, right? So class, this word how far is different from the word how fast. How far means distance. How fast means the speed or velocity. Do you get that? So we are asked to find the distance here, that is S. Please take note. The word how far means distance, while the word how fast means speed or velocity. Please take note. Now, what again they said, they gave us C, that is speed. C is given to us as, you can either call it C or velocity, it's in the same thing. The only difference here is, this one is speed of light. I hope you know that. It's given to us as 3 times 10 raised to the 8 meter per second. Please take note. So class, we have listed out the given parameters here, time taken. Of course, they not say period. If this period to be T, capital T, right? So this is time taken, not period. If it's period, they will tell you period, or they will tell you the time taken to cover one circle, okay? So this is the time taken. They said how far. How far means distance. Now the next is velocity given to us here, of velocity of light. So the difference between this C and this V here is the same thing, but this one is for light. I hope you get this. So class, we have, listen to me carefully. Are you done? Are you done? We have two velocities in terms of wave. The first one we call it wave velocity, while the other one we call it velocity only. Now, what is the difference between wave velocity and velocity? For velocity v is defined as displacement or distance over time. Please take note. For velocity only, if you are given distance, you can use s to represent distance. You can use small s to represent distance in the same thing. Now, if you are given velocity only, if you are asked to find velocity only, the definition is the rate of displacement or the rate of distance. Please take note. Okay? So, but if you are asked to find the wave velocity v is expressed as lambda over period. Please take note. There is a difference between this velocity and this velocity here. This is called the normal velocity because we are given normal time, and also normal time goes with normal distance. While in terms of period goes with what class? Wavelength. Please take note. Are you guys confused? And remember, this particular formula can also be written as 1 over t times, is it the same like this? Class, this expression and this, are they the same? Okay, let me ask a question, class. If I have 2 over 3 as 1 over 3 times 2, is it the same as this here? This and this, are they the same? So class, this and this is the same. That means this and this is also the same. 1 times lambda will give us lambda, am I correct? Over what? T. Class, are you guys confused? So we can easily also express this to be 1 over t. What is 1 over t from wave parameter? What represents 1 over t from wave parameter? What represents 1 over t? That is frequency, that is f times lambda. So it's either you use this or you use this to find wave velocity. Please take note. It's either use this to find wave velocity or use this to find wave velocity. So this is the two formulas for wave velocity. But it's different. Please take note. If you are giving period to calculate wave velocity, is this. If you are giving frequency to calculate wave velocity, is this here. But there's something I want you to understand between this guy and this guy here. This guy is normal velocity. If you are asked to find normal velocity, you use this one here. But if you are asked to find wave velocity, you use this formula here. Do you understand this now? Now class, look into the question here. Are we asked to represent the normal velocity or is the wave velocity? Look what is given to you there. Is it normal velocity or wave velocity? It is normal velocity because it's time taken that is given to you. It's not period that is given to us here. Am I correct? So I will use this particular formula to solve this. Please take note. So now let's use this formula here to solve this. So class, let's use this formula here to solve this. I will have this to be V is equal to class S over T, or you can also represent this as S, the same thing here. So class, this V can also be C here. The reason is this C represents speed of light. So let's represent this here. V is 3 times 10 raised to the power of 8 is equal to S. Is S given to us there? No. We are looking, S represents distance, right? That is how far. Do you get that? So S over, what's our time taking place, class? 4 times what? 10 raised to the power minus what? 3. Please take note. You can write. Now class, our intention here is to make this distance here the subject of formula here. Now let's make S the subject. If you make S the subject here, what will be our result, please class? To be what? 3 times 10 raised to the power of 8. What again? Times what? 4 times 10 raised to the power of what? Minus 3. Class, are you guys confused here? We cross multiplied. That is this the same thing as over 1. Remember, whenever you have division at the left hand side and division at the right hand side, the next thing to do is to cross multiply before you find what you are looking for. So there is division here because I can express this as over 1. So this time this will give us this S here. This time this will give us this here. Please take note. So I will have this to be S to be equal to class 3. Class, if you look into here, we have two bases to be the same. In mathematics, whenever you have this to be a raised to the power of n times a raised to the power of n, these two bases here are the same. You take one and add up their powers. Do you remember this? So we only use this principle of indices when the two bases are the same. So this and this are the same. So I'll multiply the numbers first. 3 times 3 times 4, what is the answer? 12 times. So this and this is the same, take only one. Let's add up their power. 8 minus 8 plus into minus 3 like this. From the law, please take note. So class, plus times minus, what is the answer? Minus. So I will have this to be class 12 times 10 raised to the power of 8 minus 3. So class, 8 minus 3, what is the answer please? 5. So class, I will have this to be 12 times 10 raised to the power of 5 in meters. Please take note. But if you look into the question, we are not asked to express this in meter. We asked to express it in meter. Look into the option, you know what they are asking, please. So how do we convert this meter to kilometer? It's very simple. The word kilo is a prefix. This word here, kilo, is a prefix representing times 10 raised to the power of 3. This word kilo is we have prefixes in mathematics. We have prefixes in mathematics. We have kilo. We have micro. Micro is mostly in capacitor. You remember, right? We have pico. Kilo is 10 raised to the power of 3. Micro, this sign here, is times 10 raised to the power of minus 6. It's mostly used in capacitor. We have pico. Pico, that is P, is times 10 raised to the power of minus 12. Please take note. So all these things are prefixes you need to know. We have milli. Milli is times 10 raised to the power of minus 3. Please take note. So you can use this to convert. Very important. But our intention here is to convert this from meter to kilometer. How do we convert this 12 times 10 to the power of 3 meter from meter to kilometer? I will divide here by 1000 because kilo is what class? 1000. Do you get that? 10 to the power of 3 means 1000. Are you guys confused? Okay. Now divide here by 1000. I will have this to be S is equal to class 12 times 10 to the power of 5 divide by 10 to the power of 3, which is this kilo here. If you want to convert anything, if you want to convert to micro, divide by this 10 to the power minus 6. If you want to convert to milli, divide by this guy here. If you want to convert to kilo, divide by this guy here. Hope you are getting this here. Please take note. So my intention is to convert to kilo. I will divide by 10 to the power of 3, which is kilo. So let's simplify this. From our indices over a raised to the power of n, that is the same thing as a raised to the power of n minus n. Do you remember this? Okay, that is for division. Remember this, we are applying this is because the base here are the same. Please take note. So I will have this to be S to be equal to class 12 times 10 raised to the power of 5 class. This and this is the same. Take only one. This raised to the power of 5. But there is one law in mathematics. Whenever you are taking anything from denominator to numerator, the sign of the power will change. The same thing here. Whenever you are taking anything from numerator to denominator, the sign of the power will change. For example, if I have something like this, 1 over s, this is the same as s raised to the power minus 1. Do you remember this? So there's an invisible one here. I'm taking this s raised to the power of 1 from denominator to where? Numerator. The sign will change to what class? Minus 1. Class, are you guys confused? So let's apply the same thing here. Let me take this 3 from denominator here to numerator. What will be the sign, please, class? Minus what? 3. So class, 5 minus 3, what is the answer here, class? That this will be 12 times 10 raised to the power of what? 2. Is it 2? In what? Kilometer. But at this point here, they express the answer to be in a standard form. So expressing this in a standard form here, I will have this to be 1.2 times 10. This 1.2 times 10 is less than 1.2 times 10 raised to the power of 2 here, which is this 2 here. So class, there's an invisible one here. 1 plus 2, what is the answer, please? 3. So this will be 1.2 times 10 raised to the power of 3, all in what? Kilometer. Please take note of that. So this is how we got this answer here. Is the option there? What option is that? B. Okay, we have that to be B. So let's go to our topic for today, open and closed pipe. So in this video, I'm gonna focus on what an open pipe is and what a closed pipe is, and also We'll solve some questions on harmonies of an open pipe and harmonies of a closed pipe. And we'll summarize by solving questions on overtone of an open pipe and overtone of a closed pipe. Do you get that now, right? So please, let's take the definition of an open pipe. Please write. An open pipe is a pipe that is open in both sides. An open pipe is a pipe that is closed, open in both sides. Note that a stringed instrument is an open pipe. Note that a stringed instrument is an open pipe. So what does it mean here? It means that all stringed instruments, you know what is stringed instrument, right? Guitar, is it a stringed instrument? Yes, you can see stringed, right? So any instrument that has stringed is an open pipe. So when they mention guitar, you should qualify guitar to be what? This class, an open pipe, okay? But there is a relationship between the linear formula for an open pipe with that of wave. So now let's consider the formula of an open pipe. Please write. Mathematically, lambda is equal to 2L. Mathematically, lambda is equal to 2L. So this is the formula that relates the linear length with wavelength for an open pipe. So if I'm given length, I can easily calculate wavelength. Am I correct? And if I'm giving wavelength, I can also calculate length from here. Please take note of this, okay? So let's take some notes here before we solve a question here. A definition for closed pipe. Please write closed pipe. I think I should just give you guys the total listen. Closed pipe. Closed pipe is a tube. Closed pipe is a tube that is open at one end. Closed pipe is a tube that is open at one end and closed at another end. That is open at one end and closed at another end. Full stop there. Full stop there. Please write. Mathematically, lambda for a closed pipe is equal to 4L. Mathematically, lambda for a closed pipe is equal to 4L. Please take note. So this is the relationship between wave parameter with that of linear parameter in terms of what? Closed pipe. But before we solve some questions here, class, let's take a note here. Please write. Please write. Note that an empty bottle is a closed pipe. Note that an empty bottle is a closed pipe. So let me ask a question here. Why is an empty bottle a closed pipe, please? Because what? You know what is an empty bottle, right? One part is closed, am I correct? While the top is what glass? Open. Do you get that? So an empty bottle is classified as what? A closed pipe, okay? Now from this particular formula here, we can now solve some questions on open pipe and closed pipe before we move into harmonies and then overtone. That's right, harmonies and overtone. Class, let's play before we take a note here. The harmonies of an open and closed pipe is the same, but the overtone of an open and closed pipe is not the same. Please take note. I hope you get that. They have the same harmonics, but they don't have the same overtone. Please take note of this, please. So let's take a note here on harmonies. Please write harmonies. Let's take a note on harmonies. This thing here. Please write harmonies can be defined as harmonies can be defined as f of n equal to n f naught. Harmonics can be defined as f of n is equal to n f naught, where f naught is equal to fundamental frequency, where f naught is equal to fundamental frequency. So class, before we further ahead here, let's know what fundamental frequency is. Let's stop writing. This fundamental frequency is the frequency gotten from the equation or the frequency in the equation. So if you are given any equation in terms of wave, that frequency you calculated from the equation or the frequency in that equation is called fundamental frequency. Please take note of this, okay? Now let's move into the next one here, that is overtone. Overtone of an open pipe. Overtone of an open pipe. Let's write overtone can be defined as the frequency over harmonies. Overtone can be defined as the frequency over harmonies. Overtone can be defined as the frequency over harmonies. Full stop there. So what does it mean here? It means that if my if my harmonies is 3, the overtone of this open pipe here, what is the frequency over this 3? Over 3 is 4, right? I hope you get what I'm saying here. Listen, please. They said overtone can be defined as the frequency over harmonies. So if I have 3 as my harmonies, so what's the number over 3? Is what? Is 4. What is the number over 4? Is 5. Do you get that? So the frequency over harmonies is called overtone. But the formula differs depending on the pipe. If it's an open pipe, we have different formula for this. Please write. Please write. Mathematically, it can be expressed as Fn equal to n plus 1 of f naught. Mathematically, it can be expressed as Fn is equal to n plus 1 f naught. So this is the simplest way to calculate the overtone for an open pipe. Please take note. This is the simplest formula to calculate overtone for an open pipe. Let's consider the overtone for a closed pipe. Please write overtone of a closed pipe. Overtone of a closed pipe can be expressed mathematically as Fn is equal to 2n plus 1 times f naught. Overtone of a closed pipe can be expressed mathematically as Fm is equal to 2n plus 1 times f naught. But before we solve the question here, class, what does this f naught represent here? What does it represent? Class, what does this f naught represent? Fundamental frequency. Please, who can define fundamental frequency here? What is fundamental frequency? Class, what is fundamental frequency? Anybody? The definition is very simple now, right? I'm not giving you guys more definition, am I correct? Class, what is fundamental frequency? Sorry? The frequency gotten from the equation, right? Or what again? You see that the frequency gotten from the equation or the frequency you calculated from the equation. Sometimes might not be given to you, right? You have to, but since you have calculated that frequency from the equation, that frequency there indicates fundamental frequency. Please take note. So let's solve a question here for you to understand the statement perfectly. Question 1, please. Take question 1, please, here. Please write. An open pipe of length, question 1, an open pipe of length 33 cm, an open pipe of length 33 cm resonates to a frequency of 1000 Hz. An open pipe of length 33 cm resonates to a frequency of 1000 Hz. Full stop there. What is A? What is A? Fundamental frequency of the pipe. What is A? Fundamental frequency of the pipe. B. Second harmonics of the pipe. C. The fourth overtone frequency. What is A? Fundamental frequency of the pipe. B. Second harmonics of the pipe. C. Fourth overtone frequency. Did you get the question? I should repeat. Okay. Let me repeat myself. An open pipe of length 33 cm resonates to a frequency of 1000 Hz. What is A? Fundamental frequency of the pipe. B. Second harmonics of the pipe. C. Fourth overtone frequency. Okay, let's solve this question here. Please do this one for me. If 1.5 meters tube is open at both ends, if 1.5 meters tube is open at both ends, full stop there. What is A? What is A? The frequency of the fundamental. What is A? The frequency of the fundamental. B. The wavelength of the first overtone. B. The wavelength of the first overtone. In brackets, you put take the speed of sound in the air. Take, in bracket open, take the speed of sound in the air in the tube to be 330 meters per second. In bracket open, take the speed of sound in the air in the tube to be 330 meters per second. You close your bracket. Let me repeat myself again. A 1.5 meters tube is open at both ends. Full stop there. What is A? The frequency of the fundamental. What is A? The frequency of the fundamental. B. The wavelength of the first overtone. In bracket open and close, take speed of sound in the air in the tube to be 330 meters per second. Close your bracket. Please solve that one for me, please. Just try your best. If a pipe is open at both ends, what pipe is it? Open pipe, right? Okay, you all know the formulas for open pipe, right? Solve that one for me, please. Whenever you are given any question in physics, the first thing to do is first list out the parameters. Okay? When you list out the parameters and you check the question to know what you are asked to calculate, that is how to solve physics. It's very simple. So if there's any condition to apply in that question, you apply the condition. Please take notes. Okay, let's solve this one here, class. Class, what is the first thing I will do here, please? I will list out what? The given parameters, right? Now, let's list out the given parameters. Given parameters. Okay, from the question, we will know the parameters given to us. Am I correct? Now, what are the parameters given to us from the question, please? Sorry? Length, okay. The length is given to us as, what is the value there? 1.5 meters. So class, is there any need for us to convert this here? No, because it's already in SI unit, right? So what again given to us here from the distance? Sorry? Nothing? Okay. Now we are asked to calculate the fundamental frequency, right? That is F naught. Please take note. Now class, since this word fundamental frequency is involved, that means it means that this particular question will be in terms of, it will be in pipe. And in terms of pipe, we have two pipes. We have open pipe and what? Closed pipe, right? Now, what pipe is that? Is it open or closed? It's open, okay? Now, in solving open pipe, we know that there is a relationship between lambda and length. Am I correct? Now, what is the relationship between lambda and length in open pipe? We say that lambda for open is equal to 2 what? Have you forgotten? Now, our intention here is to calculate for lambda, since this length is given to us here. So lambda here, class, will be equal to 2 times, what is our length here, please? 1.5, that is 1.5. So class, 2 times 1.5, what is the answer? 3 in meters. What is the next thing we are asked to calculate there? What is the next question there? This is A. What is B there? Sorry? Fundamental frequency. So class, how do we calculate fundamental frequency here, class? Now, from what I told you guys here, this is given and length is equal to this. So is there anything given to us? Is there any condition given to us there that we should take what there? Velocity, right? Should take velocity here as 330 meter per second. Am I correct? And lambda is given to us as what? Please class. 3 meters. Please stop writing, please. From this question here, we are asked to find the fundamental frequency. And they gave us a condition that velocity is given to us as this. For you to calculate fundamental frequency in this question, that you should take velocity as this. Am I correct? And remember, the lambda is already given to us as 3 meters. So class, we are asked to find F, which is frequency, but the frequency calculated from the equation, or the frequency calculated that is given in the equation, is called fundamental frequency. So we are calculating this frequency from the equation. Am I correct? So we call this fundamental frequency, that is F naught. I want to ask a question here, class. Is there any formula that connects velocity, wavelength, and frequency together in physics? What is that formula, please? That connects velocity, wavelength, and frequency. What is that formula, please? That is V, which I told you guys, V is equal to what class? F, but our F here is specified. Am I correct? That is F naught. What again, please, class? Lambda. Please take note. So let's impute the value of V here. What is the value of V, please, class? 330. So this is 330 is equal to, what is our F naught? It's not given, right? Okay, that is F naught here times, what is our lambda here, please, class? 3. But remember, our intention here is to find F naught. That is the purpose of this, is to find F naught. So class, if I have something like this, S times 3, what will be the answer here, please, class? S times 3 is what, class? Number will come first before later, right? So this will give us 3S. So the same thing here, I will have this to be 330 is equal to 3F naught. And we are asked to find F naught. The same thing here, if I have 2S is equal to 6, and you are asked to find S here, what will you do at this point, this class? Divide both sides by 2, right? So I will divide both sides by 3 here. I will have this to be, this will cancel this cancel this is 1, this cancel this is 1, this is 1 and 10. So our 110 is equal to F naught. So remember in mathematics, if I have something like this again, that is S is equal to, 2 is equal to S, is the same as S is equal to 2. Class, are you guys confused here? We just swap this guy here, we're not taking light terms. So the same thing here, if I have 110 is equal to F naught, this is the same thing as F naught is equal to 110. In what? Hence. This is our answer here, please take note. The lowest note emitted by, question 3, the lowest note emitted by a stretch string, let me spell it. The lowest note emitted by a stretch string has a frequency of 40 Hz. Full stop there. The lowest note emitted by a stretch string has a frequency of 40 Hz. Full stop there. How many overtones are there between 40 Hz to 80 to 180 Hz? How many overtones are there between 40 Hz to 180 Hz? Full stop there. A, the options are given to us. 4, B, 3, C, 2, D, 1. Okay, class, let's solve this question here. Solution first. We are asked to determine the frequency between what? 40, is it 40 Hz? Class, is it 40 Hz? To what? To 180 Hz. So what does it mean here? It means that we have to determine, is it the frequency or is overtone? It's overtone, right? We are asked to determine the overtone of this between this 40 Hz to 180 Hz. But before we determine this here, there is a key point given to us there, a string. So when they mention a string, what pipe that is a string instrument? What pipe? Open pipe, right? So whenever they mention a string instrument, the pipe that is concerned is an open pipe. So class, what is the overtone? The overtone frequency for an open pipe. What is the formula? What is the formula for the overtone frequency for an open pipe? That is Fn is equal to n plus 1 times what, this class? F naught. Do you remember this? Now class, what does this F naught represent here? Fundamental frequency, right? Check the question given to you. Is there any frequency apart from the one they told, apart from the range given to you? Is there any frequency given to you in the equation there? What is the frequency given to you in the equation there? 40, right? So our 40 represent the F naught here. That is 40 Hz. So the main thing we have to do here is to solve this in a way that we have this 40 to 180. That we have to choose 1, 2, 3, 4. So anyone that gave us this 180, between this to this will be the what, this class, the overtone. Please take note. And so we should choose anyone that gave us from how many? 40 to what? This class, 40 Hz to what? 180, right? So for n equal to 1, we'll have this to be F1 is equal to class. This is what? 1 plus 1, right? Times 40. So I'll have this to be 2 times 40. What is the answer? 80 Hz. So we choose for n equal to 2. So our F2 here will be equal to class 2 plus 1, please take note, times times what? 40. So this will give us 3, right? 3 times 40. What is the answer, please, class? 120 hands. Now we choose M to be equal to 3. So I will have this to be F3 is equal to, class, what is the answer here? That is 3 plus 1 times 40 will give us what? 4 times 40. So, class, what is the answer here? 160 hands. We choose N to be equal to 4. So we choose N to be equal to 4. I will have this to be from this formula here, class. 4 plus 1, that is F4. 4 plus 1 times 40 will give us 5 times what? 40. Class, 5 times 40 will give us what, class? 200. Class, is this value here, is it out of this range here? Yeah, it's out of this range, right? So that means our distance is between 1 to what, please, class? 3. Am I correct? It's 1 to 3. So that means 3 is there. Am I correct? So 3 is the last overtone there. Are you guys confused? Listen, do you understand the question perfectly? 1 is not giving us above this range here. 1 is seen within the range, yes. 2 is seen within the range here, all right, which is what? 120. 3 is seen within the range. So we are asked to calculate, can someone read it so you understand properly? We are asked to calculate the overtone between these 40 hands to what? 180. That means that overtone will not exceed 180. I hope you get that. So 3 does not exceed 180. So the overtone is between 1, 2, and 3. Please take note. 1, 2, and 3. Why? The 3 is this thing here. The answer. Okay, now what are the frequency? In case you're asked to list out the frequency, what are the frequency, please, class? The frequency are 80, what again, please, class? 120, what again? 160. Please take note of this. Sometimes you'll be asked to list out the frequency. So the frequencies are 80, 120, and 160. The next exam possible question here, please write. The wavelength of the first overtone, of a note in a closed pipe, the wavelength of the first overtone of a note in a closed pipe of length 33 cm. The wavelength of the first overtone of a note in a closed pipe of length 33 cm is A 44 cm, B 33 cm, C 22 cm, D 17 cm. Okay, class, listen, please. We are asked to find what here, please? This question, we are asked to find what here, please? We are asked to find what? The wavelength, right? Of which of the pipe, please? Closed pipe, right? So we're asked to find the wavelength of a closed pipe. That is the wavelength of a closed pipe here. Okay, now listen, please. But not only that, there's a statement there. They say, is it the overtone or is harmonics? Which of them? Okay, let's read it together so you understand. They said the wavelength of the first overtone, right? Now when they say first overtone, what will be the value of M, please? What is the value of M for first overtone? M is what? 1. Okay, M given to us there is 1 for first overtone. Please take note. So what again they said, of a note in a closed pipe. Now the length here is given to us here as what? For closed pipe is what? 33 cm. Class, what is the formula for Okay. Okay, class, what is the formula for frequency of an overtone? For closed pipe, for closed. That's F is what? Is equal to 2n plus 1 times what, please class? F naught, please take note. So what does it mean here? It means that if you calculate the frequency of this overtone here, and the lambda is given to you, or yes, the lambda is given to you, you can easily calculate the velocity here. Please take note. If you calculate the frequency given to you here, that is the frequency of this overtone here, and the lambda is given, or the velocity is given, you can calculate any one that you are asked to calculate. If you are asked to calculate velocity, you can calculate velocity at that point. And if you are asked to calculate wavelength, you can also calculate wavelength. Class, are you guys confused? Okay, let me explain this mathematically here. Class, we are asked to calculate the wavelength. Am I correct? Is it the wavelength? And this is already given to us here. Please take note of this. But we're not only asked to calculate the wavelength, we're not only asked to calculate the wavelength for harmonies. We're asked to calculate the wavelength for what, this class? For the overtone, first overtone. Now, so that the first overtone here, what is the first overtone here, please class? First overtone means that n is what, this class? 1, alright? Am I correct? N is equal to 1 here. So I will have this to be class F1 here is equal to 2 into 1 plus 1 times F naught here. Please take note of this. So class, is F1 given, is F naught given to us there? Is it given to us there? No. Okay, wait. Okay, wait. M is equal to 1, I is equal to 33, right? And we are asked to calculate this lambda here. Please take note of this. We are asked to calculate the lambda, but this lambda in terms of what? First overtone. Am I correct? In terms of first overtone. But let me ask a question here. Is that for closed pipe? Is there any relationship between? Is there any formula that relates wavelength and length? Is there any formula that relates wavelength and length? See there? What is the formula, please? For wavelength is what, class? 4L. Please take note of this. So this is the mathematical relationship between wavelength and length in a closed pipe. Okay? So that means our wavelength here will be equal to 4 times. So is the option given to us in cm or is given to us in meter? It's cm, right? So there's no need for me to convert this guy here. So I will have this to be what, class? 33. Please take note. That is for this. I'll have it to be 33. So class, 4 times 33, what is the answer? Is what? 132 in Cn. Now this particular wavelength now is not for overtone. This wavelength now is called fundamental wavelength. Please take note. Class, remember what I told you guys here? I told you guys that any frequency calculated from equation is called fundamental frequency, right? So the same thing applicable to this question here. Any wavelength calculated from the equation is called fundamental wavelength. Please take note of this. So this wavelength here is called fundamental wavelength, not overtone wavelength. So now how do we now calculate for overtone wavelength here, class? We have to relate this particular stuff here in terms of overtone frequency. So how do we relate this in terms of overtone frequency here, class? Remember this, that we have this to be V to be equal to class F lambda. We have this to be V equal to F lambda. So class, if I relate this frequency here, which is the fundamental frequency, this is fundamental frequency, and this will be what, class? Fundamental wavelength, right? Fundamental frequency will go with fundamental wavelength. Please take note. If I have this to be V equal to F naught lambda naught, class, at this point here, my intention is not to find the fundamental, what is it called? Is not to find this fundamental wavelength, is to find the overtone frequency. So now let's find the fundamental frequency from here. Fundamental frequency will be equal to class F naught will be equal to class V over lambda naught. Please take note. Do we have the value for lambda naught? Is there any lambda naught given to us there? Yes. Lambda naught is this fundamental wavelength here. Calculate from the formula. Okay. So this will be equal to class V over 44 in cm. Is it 44? 132 cm. Please take note. So our F naught is equal to V over 132 cm in fundamental frequency. But after this, now we can now calculate for what is class the overtone wavelength. Please just write. We have calculated for the fundamental frequency. The next is to calculate for what is class the overtone frequency. Are you guys confused? A bit confused, right? Now listen. Listen. At this point here, we are not giving parameters to calculate maybe your F1 and or. It's a kind of complex question. Okay. Now, the first thing to do here is to use the available parameters first. So the available parameter here is L equal to 33 cm. Remember, there's a relationship between wavelength and length. What is that relationship? That lambda is equal to 4L. Do you remember this? In terms of closed pipe first. So using this here, but this lambda here, remember I told you guys that the frequency calculated from the equation is called fundamental frequency, right? Now the same thing here, the wavelength calculated from the equation will be called what is class fundamental wavelength. Do you understand this now? So our intention now is to calculate for the fundamental wavelength here. That is lambda will be equal to 132, which represents the fundamental wavelength here. So relating the fundamental formula, that is V is equal to F naught lambda naught. But if this is fundamental frequency, that means this also will be what's class fundamental wavelength, right? So using this formula here, this will be V equal to F naught lambda naught. So the same thing here, making V naught the subject, since this is given to us here, making V naught the subject. Why are we making V naught the subject? Because it's only V naught that is related to overtone frequency. Do you remember the formula for overtone frequency? Do you remember the formula for closed? What is the formula for overtone frequency? Fm is equal to 2m plus what? 1 times what? F naught, right? What relates to that overtone frequency is F naught. So if we have F naught, can we calculate for that overtone frequency? Yes, right? Because m is given to us, right? What is our m there, please, class? M is equal to 1. They say first overtone. Okay, now let's calculate for this. So we have calculated for F naught, which represents the fundamental frequency. But our intention is to calculate for overtone. Is it overtone frequency, right? Overtone frequency, overtone wavelength. Overtone wavelength. So let's calculate for overtone here. That is Fn is equal to 2n plus 1 all times F naught. Please take note. So at this point here, n, they said first overtone, that is m is equal to 1. So I will have this to be class F1 is equal to 2 into 1 plus 1 of F naught. But do we know what F naught represents here? What is our F naught, this class? V over this, right? So I will have this to be class F1 is equal to this plus this will give us what class? 3, right? That is 3 F naught here. We have this to be 3 F naught. So represent your F naught here. Our F1 here, F1 will be equal to 3 F naught is V over what, please? Over 132 in cm. Please take note. So class, we have calculated for this represent the first overtone frequency. This represent the first overtone frequency. This represent the first overtone frequency. Class, if we are calculating for the first overtone wavelength, what formula will I use? Is the formula for velocity for overtone, right? So this is going to be class V1, that is V is equal to F 1 lambda what, please class? 1, please take note. At this point, in terms of the fundamental, we use V is equal to, this V is common. V is equal to F naught, right? Lambda naught. So at this point here, we will use V is equal to F1, representing the overtone frequency. We are trying to differentiate the overtone frequency from fundamental frequency. Okay, so this will be V is equal to F1 lambda 1. So class, is our F1 given to us here, class? Yes. What's our F1, please, class? 3V over what? 1, 3, right? Okay, now let's represent this. Please, you can write. Though it's a kind of complex question, but just try to understand this perfectly. So class, let's represent this here. This will be V is equal to F1 is already given to us here. That is 3V over 132 in cm. Don't forget. Times lambda 1. That is this lambda 1 here. If you look into the question here, we are asked to calculate for the overtone wavelength. Remember, lambda 1 represents the overtone wavelength, right? While lambda naught represents what, class? The what? The fundamental frequency, right? Now let's make this guy here the subject. To make this guy here the subject, I will cross multiply. This is the same as 3V lambda 1 is equal to class 132 cm. That is, this time this will give us this here. Cross multiply, you have this. So our lambda 1 only will be equal to class V1, sorry, that is V also. Lambda 1 will be equal to class 132 cm V over, that is 3V. This will cancel this here. So our lambda 1 only, class, will be equal to 132 in cm divide by 3. So class, can we divide this guy here? Is it possible? 132 divided by 3, what is the answer? 44. So we have this to be class 44 cm. This is our answer here. Please take note. It's complex, right? That's why it's called JAMB question. You know, the main JAMB question is always hard, and this is 1990 something. It's not like CBT question. You know, those 1990 is always complex, right? Compared to that 2027 and all. So this is 1999. Some of you are not born that time, right? If you are born, let me see hand up. 1999. From here, that is V equal to F naught lambda naught. What parameter will you use to solve this here? It's for fundamental, right? You might not put F naught lambda naught actually. You can also put this to be this here. That is V equal to F lambda. They all represent F naught here. They all represent lambda naught here. But just understand that whenever you are solving for fundamental frequency, that lambda or wavelength you are calculating at that point is for fundamental wavelength. Please take note of that. So after looking for the fundamental frequency, why are we calculating for fundamental frequency? Because in terms of overtone, remember they mentioned overtone, right? It's from overtone you will get overtone wavelength. And it's from overtone wavelength you get up class overtone frequency. Do you understand that? So the only way for us to look for overtone wavelength is for us to know overtone frequency. And the formula for overtone frequency is Fn is equal to class 2n. I told you guys now, right? Plus what? 1. For closed, am I correct? There is different formula for overtone frequency for closed and for open. Do you remember the formula? Okay. Now for closed, the overtone frequency is Fn is equal to 2n plus 1. This is the shortcut formula, F naught. You might not see it like this in your textbook, okay? Now at this point here, n, they say is force. The word force means that n is equal to 1. Now replace this as 1 here, you will get this. But our intention for calculating for fundamental frequency is to calculate for the overtone frequency first. So when you calculate for fundamental frequency, we've got fundamental frequency to be in an expression. That is F naught to be this V over 132 cm. So at this point here, they want to deceive most of you. You can imagine getting something like this. You would think that the answer will not be there. Am I correct? So this is our F naught here. So, but when you solve the overtone frequency, we got the F1 to be 3 F naught. Anywhere I see F naught, you represent F naught as what class? V over what? 132, which is this one here. But remember this, F1 will be equal to, when you make F1 will be equal to 3V over 132 Cm. But our intention is not to find the overtone frequency. Is it up to 6? Is it up to 6? 6 what? Okay. Now our intention here is not to solve for the overtone frequency. Our intention is to solve for the overtone wavelength. Where do we get wavelength? Is V equal to class F lambda, right? But this one now is now representing for overtone, not for fundamental now. So this will be V equal to F1. We are using F1 to represent overtone. Lambda 1. So class, this is common. The velocity is common in both. So replacing F1, I will have something like this. If you replace F1, this is 3V over this. That is for F1 here. Lambda 1. I want to close. Now, class, our intention here, our purpose here is to make lambda 1 the subject. Making lambda 1 the subject here, we have this to be 132 cmv over 3v. So this v will cancel this v here. I'll be left with 132 cm over 3. So our answer here will be equal to 44 cm. Do you get that now, right? So it's a kind of complex question, but please just try to understand. Is anyone